Alright guys, for numbers 1 through 5, I'm asking you to identify which variable is the input. Now just so you guys know, technically I could also ask which one's the output. So even though the answer we're going to give is the input, I will also show you guys how to identify the output. A good thing to look at for this one would be our 2.1 notes that we took. In one of the very first slides, it was the one that looked like this. Might help you guys out a lot. We wrote some more stuff on here. So hopefully you guys have that. Let's go ahead and go through this a little bit here. So for number 1, matter of fact, I'm just going to write my answer like this. It's just a little bit easier. So for number 1, the input is the one that's in parentheses. The output is the one outside the parentheses. But you could also say it's f of m, the whole thing, on the left. Because it says here that f of m and n are equal, so technically either one of those are good. Okay? Let's go ahead and take a look at number 2 here. Number 2, L depends on Q. Okay, whenever it's written as a sentence, the letter that comes last is the input, the other one is the output. Number 3. Same thing here. The one that comes last is the input. The first one is the output. Number 4. Whenever you have something written as an equation, the variable that's all by itself, in this case the u, is the output. The other one that has stuff with it would be the input. On number 5, whenever you're trying to find out which one is the input and output, the input is the one that's always on the horizontal axis. The output goes on the vertical. And so that's how we can kind of tell. And just so you guys know, back to number 1, technically you could also say f, although that's not very common because f just represents the function, whereas f of m represents the value of the function when you plug in m. So it's better to say this than this, but it's okay technically. But n is also a perfectly fine answer. Okay, so 3 different possibilities there. Let's go ahead and take a look at numbers 6 through 9. Determine if a expression represents a function of x. So something is a function if every input has only one output. Okay, so in other words, if I have a function and I plug in 2, I should get one answer out, whatever that number is. I shouldn't get f of 2 equals 4 or 6. Okay, it should only give me one answer. If it doesn't give me only one answer, then it's not a function. Now, there's 2 ways that we can look at this. One is as a table and the other one is as a graph. Now, when you're looking at tables, the input row should have no repeats. Because if it has a repeated value, that means that that one number goes with 2 different outputs and it's not a function. Now in this case, the input is x. So here's my input row. So I'm going to look across this entire row. Do you see any numbers that are repeated there? No. So what that means is every input has only one output. 4 goes with 1, 5 goes with 1, 9 goes with 2, 8 goes with 4, and 0 goes with 4, and we're good to go. So every input has only one output. And yes, I understand that some of them have the same output, but it doesn't matter that they have the same output. It matters that each input has one output. Now when I look at number 7, when I look at my input row, I see that 1 is written twice. And that means that when x equals 1, the output can be 4 or 5. So that is not a function. So anytime you have repeated input values, then that's going to be a no. So this one's not a function, f of x equals y. And this one is a function, f of x equals y. And just so you guys are aware, if I were to reverse the question, if I were to say, is this true? Now that would mean that instead of starting I would have to change my table a little bit so it's less confusing looking. But that would change one thing. You have to make sure you know which row is the input row. Okay? So there's that. Now, when you're looking at a graph, how can you tell when an input has one or more outputs? Well, remember, when you're looking at a graph, the input is always on the horizontal axis. So let's go with the input x equals 2, for instance. There are 2 points on this graph where we have an x value of 2. This one's probably like, it's hard to say, maybe like negative 2.5 for the y value, and up here this one looks like maybe 0.5. But the point is that for the input of 2, there are 2 different outputs. Now that's complicated. There's a much easier way of doing it. The way you can tell with a graph is by doing something called the vertical line test. Okay, so if you could draw a vertical line and it hits the graph twice, that means for that one input there's 2 different outputs, and that would be a no. That's not a function. That's not a function f of x equals y. Anyway. Now, for the next one, here's my input row. So for this one, no matter where I draw a vertical line, it only hits it once. That means every input has 1 output, so that would be a yes. Okay? All right, now numbers 10 through 18, we're putting together a lot of stuff that we've learned throughout a few different lessons. We're looking at evaluating, we're looking at solving, we're looking at inverses, we're looking at composite functions. We're looking at all kinds of things there. So there's a lot going on here. So pay close attention. But you can't really just turn to lesson 2 and know how to do all this stuff, because these problems are kind of scattered throughout everywhere. Okay? But what is going to be important here is, can you identify the input and output? So in this case, A is my input. Okay? So I want to look at the input row, which is the x here. How do we know that? Let's see. So right here they're saying that, f of x is one of my functions, g of x is the other one, x is the input, so this is my input row. And we have 2 different outputs because we have 2 different functions. Now some of you guys might be thinking, wait a minute, Mr. Bailey, didn't you say earlier if there's 2 outputs for one input, it's not a function? Well, yeah, but what I mean is that if you plug A into F, how many answers do you get? You only get 1. Okay? So that's still a function. The reason why we have 2 outputs here is because I've got 2 different functions. So if I plug A into F, I get B, but if I plug it into G, I get a different answer. And that's okay because we're talking about 2 different functions. So I don't want you guys to mix that up with what we learned in the last set about not having 2 outputs. But anyway, back to our problem here. F of A equals what? So this means I'm going to go to the A in the input row, and I'm going to look for the output in the F row. Okay, so here's A, and in the F row, the output would be B. So the answer is B. Let's go ahead and take a look at number 11. Now for number 11, I don't know what the input is, but I do know the output is A. So that means I'm going to go to the output row, and I'm going to look for an A in the output row, and there it is. And I want to know what's the input that goes with that. It would be C. All right. Now number 12 gets us into some other interesting territory here. So let's talk about that a little bit. Now we're talking about inverse functions. All right. So if I tell you guys that g of x equals y, then that means that g inverse of y equals x. All right. So there's a few ways you guys could do this, but here's one way you guys can kind of handle this. Instead of writing it like this, we could rewrite it like this. So in other words, I'm looking for the output B and wondering what the input is that goes with it. And we're in the G function row. So I'm going to go to the G function row, and I'm going to look for where the output is B and the input that goes with it is D. So the answer here would be D. Here's another one. Once again, if we rewrite it as a G function, not a G inverse, but just a regular G function, the B ends up here, and the question mark is here. So now I'm looking for what's the G value when the input is B. Well, my input is B here, and the G value for that would be E, is the answer. Now, number 14 is what's called a composite function. When you have composite functions, you start with the inside first. So let's do G of D. So I'm going to look for the G value when the input is D. So the input is D. What's the G value? It's B. So I'm going to replace G of D now with what G of D equals. G of D equals B. And now I get to do this part. Now I want to look for what is the F value when the input is B. When the input is B, the F value is D. And that's our final answer. So with composite functions, you start on the inside and you work your way out. Let's look at another one here. Same kind of question, just a different one. In this case, we're going to start on the inside F of D. So I want to find what's the F value when the input is D. Input is D, F value is C. So I can replace that part that I circled there with C. Now to find this thing, to evaluate that, I want to know what's the G value when the input is C. So when the input is C, the G value would be A. Final answer. All right. 16 is like a combination of the last few problems. There's an inverse there, but it's a composite function. Okay? So, G inverse of E. So let's do that first. Let's do G inverse of E. Well, I don't know what that is yet. But I do know that since it's an inverse, I can rewrite it like this. And now I know that I'm wondering what's the input when the G value is E. So let's find the G value, and the input that goes with that is B. So that means that G inverse of E is equal to B. So if this part here is equal to B, then I would just replace it with B. Now F of B means I'm going to look what is the F value when the input is B. So input is B, F value is D. All right, moving on, number 17. So how we're going to handle these ones is we're going to figure out what each piece is, and then we're going to do the math. So I'm going to figure out what's F of C, then I'm going to figure out what's G of C, and then I'm going to divide them. So let's do that. So what's the F value when the input is C? That would be A. What's the G value when the input is C? It's also A. What's A divided by A? Well, it doesn't matter what the number is so long as it's not 0, because you can't divide by 0. But anytime you divide a number by itself, you end up with 1. So the answer would be 1, because any time you divide something by itself, you get 1. Let's go ahead and take a look at number 18. Same thing. Evaluate, then do the math, and get your answer. So let's see. What is the F value when the input is E? It's E. What is the G value when the input is B? It's also E. What's E minus E? Well, anytime you subtract a number from itself, what do you get? 0. That's weird. We just turned letters into numbers. Isn't that weird? All right. Let's go ahead and move on here a little bit. So that's table stuff. You want to make sure you know how to do tables. Now we're going to look at some interpretation stuff. How do you turn symbols into words? Okay. F of t represents the number of females at LNHS t years after the year 2000. So F of t, in brief, represents number of girls at LNHS. T represents the number of years after 2000. So like this year, for instance, is 2020, right? Well, then in this case, t would equal 20, because that's been 20 years after the year 2000. M of t represents the number of males. And now we want to interpret it. So f of t is the number of females, m is the number of males. What do you get if you add those together? You get the total number of students. Now this is the same expression, but I put a number in there. And you'll notice that that number is where the t is at. And t is the number of years after 2000. So it still means this is the total number of students, because we're still adding the number of females to males. But since we're actually plugging a number in for t, that means it's the third year after the year 2000. So what this expression represents is the total number of students 3 years after the year 2000. So you could just say 2003 if you want to, or you can actually write out the phrase 3 years after the year 2000, whatever works for you. Let's interpret this one. This is the number of girls in the year 2002. Is 52 more than, because we're adding, right? 52 more than the number of males. So the number of girls in 2002 is 52 more than the number of males. So all that means is that the number of girls in the school is 52 more than the number of males. All right? And so that's interpretation. So you guys will notice how I started here on the side. I started by writing what my input represented, and then I wrote what my two outputs represented. Once I have that as kind of like my key to go to, I can interpret these one piece at a time. Okay? Technically here, you instead of saying the total number of students, you could have also just said the number of females plus the number of males. That would be fine. Or here you could have said the number of females in the year 2003 added to the number of males in the year 2003. So let's go ahead and continue our exploration here. So now we're going to talk about doing all the stuff that we've done with functions, but not from tables or graphs, but now with actual equations. So how these ones work is basically you're just going to replace the g with what g equals and the h with what h equals. So in other words, g of a is going to be a squared minus 4. I would encourage you guys to use parentheses. Plus, and then the h function, 4a minus 4. After that, do the math. Simplify this expression. So we have a squared. Negative 4 makes negative 8, and then 4a goes in the middle there. And so there you go. So replace the functions with the actual equations that they are, and then simplify. Okay? Tried not to make these things too complicated because we're not really focusing in this chapter on how to do simplifying so much as just how to work with functions. And so most of the simplifying I'm going to be asking you guys to do in this chapter is basically just adding and subtracting, maybe some sparse multiplication, not much. It shouldn't be hard stuff. It should just be just straight up. So let's do another one. F of n minus g of n. F of n minus g of n. F of n is n minus 1, and g of n is n cubed minus 1. Now when you're subtracting, you need to distribute the negative. And if we combine our like terms, those cancel. So here's my answer. It's possible to write your answer with the cube in the front instead. So either one of those are good answers. But there you have it. Let's go ahead and take a look at the next one. F of x times g of x. So we have f of x multiplied with g of x. f of x times g of x. So here's some multiplication. Whether or not this is going to be interesting, I'm not sure. I don't remember if I put it on there. So let's just say it is fair game. There's nothing wrong with me asking you guys to be able to FOIL. I don't know if I made one on there because I don't know. It's just kind of a little out of the blue. I guess we haven't been focusing on this kind of stuff a whole lot. But you can use the FOIL method or you can use the box method. So x times negative 2x is negative 2x squared. X times 1 is x. 1 times negative 2 is negative 2x. And then 1 times 1 is 1. And so we have now all those four things put together. We have negative 2x squared. We have an x. We have a negative 2x. And we have a 1. And we can combine our like terms here and get that final answer. Okay. Let's do another one here. This is a composite function. So the way I taught you guys how to do this was to start by writing the inside function first. And then you write the outside function underneath of it, but with blanks where the x's were. And then what you do is you drop the inside function down into the blanks. And we're going to go ahead and simplify this because all that we need to do is distribute and combine some like terms. That's not something that I would expect you guys to have trouble with. So that's going to be negative 9x squared minus 6x minus 5. There you go. All right. Let's continue our talk about equations here. So for number 24 and 25, what we're doing is we're finding inverses. All right, so what we talked about when we're finding inverses is the first thing that you want to do is you want to replace the f of x, or in this case h of n, with a y. Just some single letter. It just makes it a little bit easier to work with. The next thing you do is you switch the letters around. And then the next thing you do is you try to get the y by itself again. Okay? So in this case, we've talked about what Mr. Bailey likes to do when there's fractions. When there's fractions, I like to multiply everything by the denominator. So here we end up with just 2n. Here the 2's cancel and we're left with just y, negative y actually, because that negative is still in the front. And then here, those cancel, leaving us with 5. Now I would minus 5 on both sides to get the y by itself. And then I would divide everything by a negative 1, which will just change all the signs. Good way to check to see if you got this one right would be to plug in a number. So I mean, for instance, if you plug in 0 for n, that cancels out and you're left with 5 halves. So when I plug in 0, I get 5 halves. Well, if you plug in 5 halves down here, you should get 0. Let's go ahead and take a look at the next one there. Same thing. This one's a little bit easier, actually. Replace the h of n with y, switch the h and n around, and get y by itself. This one was a little bit easier to get the y by itself. And I didn't do this in the last one, but you can. We can replace the y with this symbol here, but now that it's an inverse, we put a little negative 1. So you could do the same thing here with this one, replace the y with h inverse of n. And that's how you do inverses. Okay. Next, we're going to look at evaluating. So it's pretty similar to some stuff we've already looked at, but now we're actually plugging numbers in. to these equations. All right. So for this one, what this is telling me to do is this is telling me to plug 3 into the g function and multiply it by 4. This one's telling me to plug 3 into the f function and multiply it by 4 afterwards. When we have those two answers, the last thing we're going to do is subtract them. So we're going to multiply the g function by 4 and the f function by 4 after we plug 3 into the equation. So the g function is t squared plus t, and we're plugging in 3 for that. The f function is 4t, looks like minus 5, and we're plugging in 3 there. So plugging 3 into the g function, we get 9 plus 3 is 12. Plugging 3 into the f function, we get 12 minus 5 is 7. Now we're going to multiply each of those by 4, and then we subtract. Final answer. So the number in parentheses is what you're plugging in, and in this case that means multiplication, of course, by 4, and then we have the subtraction. So it's just basically decoding what the problem's asking you to do. Let's do the next one here. For this one, it's asking me to plug in -2 to the g function and also into the h function. After I do that, we're going to multiply those results together. So let's plug 2 into the g function. I'm going to show my work a little bit differently this time. What is g of -2? G of -2, it means we're plugging -2 in for x. So I get 1. So g of -2 equals 1. So I'm going to replace that with 1. Now I need to do this one. So let's do h of -2. What's h of -2? I'm going to plug in -2 into the h function. That's 4 take away 2, which is 2. And now we multiply those together to get 2. Okay? So one way you can do these problems is just like write out the whole thing like I did and simplify it, which is kind of hard for you if you're not really great with order of operations. The other way, like I did in 27, is just evaluate the function first and then do the operation afterwards. So I evaluated both of these and then I did the operation of multiplying them. All right, number 28. Let's evaluate first. I'm going to go with the evaluate first method. So that means I'm going to plug 7 into the g function, which gives me 22. Next, I'm going to plug 7 into the h function, which is going to be 49 minus 2 is 47. I'm sorry, 49. No, it is 47. My bad. 47. And then we divide those. So what is 22 divided by 47? Well, it's not a nice answer, so they'll probably just write their answer for that one like a fraction. 22 over 47. Let's take a look at number 29. So this is a composite function. So what this means is I'm going to plug 9 into the g function, so let's do that. -36 take away 4 is -40. So since g of 9 equals -40, I'm just going to put that there, where g of 9 was. Now that tells me to plug -40 into the f function. Watch out for those double negatives. I'm getting 45 as a final answer on that one. All right, so that's equations. And now we'll talk about graphs a little bit. A lot of stuff here to do with graphs, so let's go ahead and begin. All right, so we have two functions here, g, which I'll represent with green here. Kind of hard to draw here. And then f is going to be the blue one, okay? So there's that. So f of 2. So you got to remember that my output is y, my input is x, so that means these are functions like this. So when I say f of 2, that means that x equals 2, and we're wondering what's the y value. So for the f function, the blue line, when x equals 2, which is right there, what's the y value? The answer would be -3. For number 31, we're looking at the g function, the green one. For that one, they're telling me the output, which is y, is 8. So we want to find where does the y value equal 8, and that would be right up here. So what's the x value that goes with that? That would be 4. Number 32, same thing, just a composite function. So the first thing we're going to do is we're going to figure out what is g of -2. So how would I find that? Well, if I'm looking for g of -2, that tells me that x is 2, and I want to know what's the y. So on the g function, what is the y value when x equals 2? That would be a y value of 6. So g of 2 equals 6, so I can replace that with 6. Now I need to figure out what's f of 6. So the number in parentheses is an x, so that's x equals 6. What's the y value that goes with that? So on the blue line, the f function, when x equals 6, what's the y value? That would be 5. Okay. Next one we'll look at. Clean this up a little bit. Let's take a look at number 33. So what's f of 6? So what's the y value on the f function when x equals 6? That would be 5. It's right there. When x equals 6, y is 5 on the f function. And now we want to know what's the y value when x equals 5 on the g function. Here's where x equals 5 on the g function. The y value for that is 7. Next question is asking us, what is the domain and range of f? Domain is all the possible values of x. Range is all the possible values of y. Now we're looking at the f function here. So when you're talking about x, you're talking about how far to the left and right does it go. The farthest to the left is here, the farthest to the right is up here. So the x values for those points are 2 and 7, and since those are closed dots, we'll go ahead and put an equal sign. Another way you could write this is like this, by the way. Oops, it's supposed to be 7. With brackets. You use brackets when it can be equal, use parentheses when it can't. For the range of f, we're looking at the lowest point and the highest point. Y can be anywhere between the lowest and highest. So the lowest point, once again, is down here, the highest is here. So the lowest point would be -3, and the highest point would be, looks like 9.5. And once again, those are solid dots, so we would use brackets. All right, now the next thing is asking us to sketch f inverse of x. Sketch f inverse of x. How do you do that? Well, the way that I showed you guys was to, first of all, pick a few points off of the f line, label them with their coordinates, and then what we're going to do is we're going to rearrange those. We're going to flip them around. So that's because that's what inverses do. They switch the x's and y's around. So switch that around. -3, 2. So my graph doesn't have a -3 on it, so I guess I'll have to be creative here and make it a little bit longer. It's -1, 2, and 3. All right. So if If I reverse this as negative 3, 2, that's going to be left 3 up 2 right about there. Next, if I switch those around, that's negative 1, 4. That would be right there. If I switch those around, 5, 6, that's going to be like right about here. And if I switch the last one around, 9.57, here's 9.5, and then up 7 would be like right about here. That didn't turn out quite as nice as I'd hoped. You know what? I think I put this point in the wrong spot. That 6.5 was supposed to be right here. Sorry about that. And then 9.57 would be like right here. Still doesn't look quite right to me. Something's funky there. It might be just because I made my own graph. Negative 3, 2, negative 1, 4. 6.5 is 5, 6. Aha! I still didn't get this point right. 5, 6 would be up here. There we go. Now that looks better. And what it should always look like is it should always look like a reflection in this dotted line. A diagonal dotted line there. Now what's the domain and range of F inverse? Well, the domain and range of F inverse will be the same thing that we had for the domain and range of F. It's just that it's all going to be reversed. So let me show you what I mean by that. I mean, you could do it the old school way by just literally doing it the same way we did the other one, just looking at the other graph instead. But if this is the domain and range for F, then the domain and range for F inverse will just be reversed. So for instance, this range becomes this one's domain, and this one's domain becomes this one's range. But you can also do it just by looking at the graph you drew and trying to figure out what the domain and range would be off of your graph. The only downside of that would be is if you didn't draw your graph right, you just got this question wrong as well. So it's kind of nice to do this other way because it's faster and it prevents mistakes. But let's go ahead and take a look at the next one here. F inverse of negative 1. All right, well, if F inverse of negative 1 equals blank, then that means that F of blank equals negative 1. That's what inverses do, right? So in other words, I want to know what's the x value when the y value is negative 1 on the f function. So the y value is negative 1 right there, and the x value that goes with that would be 4. Next one. F inverse of blank equals 7. Can be thought of as f of 7 equals blank. So in other words, if x equals 7, what's the y value for the f function? So for the f function, when x equals 7, the y value is 9.5. All right, the last thing we're going to do is we're going to graph. Now, most of you guys prefer the table method for graphing, so that's what I'm going to go with. But there was a faster method, and if you felt comfortable with that, feel free to do it. Just make sure you got it right. Okay? So, when it comes to doing the graphing of a combined function, what you want to start off by doing is set up a table. So to set up your table, you need an x row. You need a row for one of the functions and another row for the other function that you plan on combining together. Now the first thing you do is fill in your x values. So just look at all the points on one of the functions. You only need to use one of them. And write down all the x values. So from left to right, the x values are 2, 4, 6, 7. Those are all the x values. You could have picked the g function, but it wouldn't matter because they have the same x values. I made sure that they were the same. It just makes it a little bit easier. Okay. because they do have to have, you have to be working with the same x values when you do that method. So we're just going to work with the x values there. Now the next thing you're going to do is you go through and put the y values for each of those. So when x equals 2, what's the y value? When x equals 2, what's the y value for the f function? The y value there would be negative 3. How about when x equals 4, what's the y value for the f function? That would be negative 1. When x equals 6, on the f function, the y value is 5. And when x equals 7, the y value is 9.5. We're going to repeat that now, but now we're going to do it for the g function. So when x equals 2, what's the g value? So when x equals 2, the y on the g function is 6. When x equals 4, what's the y value? It's 8. When x equals 6, it's 6. And when x equals 7, it's 5. So there's your setup. That's how you set it up. Now what we're going to do is we're going to actually do the problem. The problem is asking us to graph g of x minus f of x. So now I'm going to create a new row, and that new row is going to be f of x minus g of x. So I'm going to, for each column here, I'm going to take the f value and subtract from it the g value. So f minus g. What is negative 3 minus 6? It would be negative 9. F minus g. F minus g. What's negative 1 minus 8? It's also negative 9. F minus g. 5 minus 6 is negative 1. F minus g is 4.5. So step 1 is to set up your table. Step 2 is to complete your table for the combination you're trying to do. The next thing I would do is I would turn these into points. So like 2 and 9, negative 9 are going to go together to make a point for me. 4 and negative 9 are going to go together to make another point. 6 and negative 1. 7 and 4.5. And we just plot those 4 points and connect them. So 2, negative 9 would be off the chart. So I guess I'll need to be creative here just a second. So off the chart. So we're at negative 2. This was 4, 6, 8, 10. All right. So 2, negative 9. So over 2 down 9 would probably be like right about here. 4, negative 9 would be right here. 6, negative 1 would be here. And 7 and 4.5 would be right about here. And so if I were to connect those, it would look something like that.